and evaluating polynomials. Let me get it in the little thing here. Okay, polynomial. An expression. Thank you, Valeria, for reminding me. I don't even know what day it is. Okay, an expression. I was just joking. An expression written as, okay, here we go. Sum. What does sum mean? Okay, addition of terms. We've talked about what terms are, okay? Consisting of constants. What are constants? Numbers. Variables. What are variables?
Exponents.
Letters. Excuse me. With, okay, here's what's important. Non-negative exponents. Or product. What's product mean? Very good. I'm going to put an X, meaning times. Of a constant. What's a constant? Numbers. And one or more variable. Okay. So you can't have non-negative exponents. I mean, you can't have negative exponents. That's what I'm trying to say here. Now, I'm going to explain that to you, okay? Because that's a lot of weird stuff right there. Once I write the example, you're going to be like, oh, okay, I get what it's saying here. It's an expression written as a sum. It could mean subtraction too, by the way. Of terms consisting of constants, numbers, letters, and the letters have to have positive and exponents, right? Can't have negative exponents. I've told y'all that. Or it could be the product of a constant and one or more variable. Let me show you what that looks like. Now make sure your notes are nice and neat. Franz, write all this down, please. Miranda, you got all this? Valeria, you got all this? Are you still writing? Okay. All right, here we go. Monomial. Monomial. Bless you. Means one term. Makes sense, right? One term. It will look something. Now, these are examples. There. Monomial. Guys, it's this whole thing. This is one term. Now, to go back up to here, I want y'all to look at this real quick. All y'all real quick, look right here. What is happening with all these things? What operation's taking place? Multiplication. So look, product of a constant, here's my constant, and one or more variables. I guess that should be this. I don't know. I have my variables and non-negative exponents. That's a I don't know why they don't say positive. That's so dumb. Why not say they have to have a positive exponent? Okay, non-negative. So it means positive. So this is one term. Okay, so polynomial is an expression written as a sum of terms. Now we're not adding a bunch of terms here. This is one term consisting of constants, variables, with positive exponents, or product, that's what this one is, of constants and one or more variables. That's what that is. So let's look at what a binomial is. That's two terms. An example would be, Franz, 5x squared plus y squared. All right. That right there is two terms. Here's a term, and I know I always tell you to circle the sign in front, but for these purposes, I want to just circle the terms. There's a term and there's a term. Two terms. Do y'all see that? And right here, a polynomial, this is a polynomial because it's an expression written as a sum. Well, there we are. We're adding two terms. Do y'all see that? Yes. Not always. Not always. That's a very good question. And we'll go into that. Trinomial. How many terms do you think this one is? That's right. Write it down. 3 terms. So for example, if I had 2a squared b to the 5th power plus 8c to the 4th power minus 2a to the 5th power. This is a term, this is a term, and this is a term. This one is 3 terms. Any questions so far? Those of you in the back, if you cannot see, let me know. So these are our 3 different types of polynomials. A monomial, binomial, and trinomial. And you can subtract in between, add, or you can just have one term, like what it says right here, product of a constant and one or more variables. We can't. We can't. We're going to be getting into that. Any questions? But this is still a polynomial. See, I've been doing polynomials and didn't even know it. All right, here we go. Star x cubed y to the negative 2. Oh no, we have a negative exponent. Can we have a negative exponent?
No.
No. Or see that exponent in the denominator? Both of those are examples of what is not a polynomial. Both of these are not polynomials. Who can tell me why this one is not a polynomial? Because after all, those are positive exponents, Franz.
There's no constants?
No, it's okay. You don't have to have a constant. No.
It's not a sum. It's not adding a constant.
Well, neither is this.
It's a fraction.
Okay. And if I were to move this up here, what happens to that exponent? It becomes negative. So basically, look at this right here. Look at this term. If I were to say, oh, I can't have a negative exponent, so I got to make it positive. If I bring it down here, it's the same thing. That's why if you have a term That's like a fraction and it has an exponent in the denominator. It is not a polynomial because in reality, that would be considered a negative exponent if it was on top. Okay? Yes, ma'am.
What if you have a fraction that is having a negative in the bottom?
If it is a negative in the bottom and you brought it on top, so that'd be a positive, I think that'd be okay. I think that would be okay. I've never seen that before in this, but I think it'd be okay.
So if there's ever a negative exponent, it's just not a polynomial?
That is correct. Okay. Can't have, or any exponent, I think. Yeah, negative. You can't have any negative exponent. I'm writing my notes down right now. Or an exponent in denominator. A fraction. Now, New had a good point. She said, what if the exponent in the denominator is negative? Therefore, it would make it a positive exponent on top. I think that would be acceptable.
So is it
If there's a negative exponent in the denominator, it might be. You won't have that, I don't think. Okay, so now we're going to learn about degree of terms. All right, this is interesting. It's not difficult, but it's hard to remember what the rules are. Degree of term. When they say, what's the degree of the term? It is the sum, and that's adding, it truly is, of the exponents of its variables basically, in other words, add the exponents of the letters. So if they ever say what's the degree of the term, all you're doing is adding the exponents of the letters. Make sure you're taking good notes because you may forget how to find the degree of the term. I'll let y'all catch up. So degree of term, if they ever say what's the degree of the term, you're adding all the exponents of the letters.
What if there's negative exponent?
And it's not a polynomial.
So then you wouldn't have to do that?
Nope. Good question. Okay, so for example, here's a term. What kind of polynomial is this?
Oh, trinomial? No, one, sorry.
Monomial. That's one term, guys. There's no plus or minus sign in between there. So that is one term. That's a monomial. So if I were to say, what is the degree of this term? You would add the exponents of the letters. It'd be like 3 plus 2 plus 4. What do you get? Raise your hand. Franz?
9.
Yep. You're basically adding the exponents. 3 plus 2 plus 4 equals 9. Any questions? Valeria, how you doing? Keith, how you doing back there? All right. How about this one? Miranda, you're my victim. What would the degree of this term? What? Yes, ma'am. Good. Because even though this doesn't have an exponent, what would it be, Franz?
1.
That's right. So then 2 plus 1 is 3. Yes, chap.
So, you know how, like, on the denominator thing where you couldn't have an exponent in the denominator?
Wait, yes.
Could you have, or you like y in a denominator, like without an exponent? Because technically it would have 1.
I don't think so. Let me see. I don't think you can have any exponent in the denominator. All right, any questions about degree of term? Miranda, you got it? Okay. Okay. Degree of a constant. What's a constant?
A number.
Numbers. This one is 0. And I'm going to, you know what, I'm going to move past this for a second. I'm going to come back with some better examples. Okay? So write that down, and I'm going to come back to it. Degree, it'll be best explained later, of a polynomial. Okay, so degree of a term, that's the individual term. This one is going to be degree of the polynomial. All right, here's the rule. It's the highest degree of any term in the polynomial. The highest degree of any term in the polynomial. All right, for example, and I'll let y'all write that down first. So they say, what's the degree of a polynomial? This is how you would find it. Let's say I have 3x cubed y plus 2x minus 4xy squared. How many terms are in this, Valeria? Huh? Which is it? Huh? It's a trinomial. Look here. 1, 2, 3. So we have 3 terms. It is a trinomial. Now, do you see that now? Okay. Degree of polynomial. It's the highest degree of any term. So what we need to do is find out what's the term, like what we did over here, of each of these. The degree of each term. What would be the degree for this term? Let's see, Sophia. 4. Does everyone see that? Keith, do you see that? Okay. Ariel, what's the degree for this term?
1.
Very good. What's the degree for this term, Chap?
3.
Very good. Does everyone see that? See, we're adding 3 and 1. This is 1, and that's 2 and 1. Okay, so which is the highest degree? Franz?
The 4.
That's right. So you ask yourself, which is highest? And it's 4. That's how you find the degree of a polynomial. See, the stuff isn't like hard to understand. It's almost like it's so simple to the point that people tend to overthink it. You know what I'm saying? It's just black and white. Problem is remembering what to do for each of the questions. Like if they say, what's the degree of the term and what's the degree of the polynomial? Remembering how to do it. But just adding the exponents, that's not bad, right? That's not bad at all. Okay. Another rule. Write polynomials in descending order. Descending order. For example, let's say I have 4x squared plus 3 plus x plus 6x cubed. Valeria, how many terms do I have there? One, two, three, or 4. That's right. There's 4. 1, 2. See, constants can be by themselves. 3, 4. Is this in descending order? No. Did you say yes?
No, I said no.
Oh. No, it is not. So we're going to write it in descending order, and we're going to do 6x cubed, then 4x squared, then the regular x. And guess what comes last? Constants. Constants come last. Nobody likes them. Constants come last. Chat.
Does that go to the degrees or the exponents?
Okay, well, they're going by exponents. See,
What if you had
multiple variables. I'm about to do that one. Yes, New?
What if it's well, not negative, subtracting is not all?
That's okay. You can have subtracting. Like right here,
how do you write that?
Yeah.
Like,
it doesn't matter. Like, okay, then this follows that term.
So it's just included.
Yeah, that's a good question. So what New is saying is, what if it looked like this and you had to rearrange this in the correct order? This negative sign follows this term.
So it would go behind it?
What is it behind it right now? That's right.
So it would just be negative 4, blah, blah, blah.
That's right. It's kind of like when we combine like terms. I'm always telling you to circle the sign right in front of it. That's what we're doing here. The only reason I didn't is because I want y'all to focus now on how many terms. That's what's important right now. Here's another example that kind of explains Chap's question. What if I had 2xy minus 7x squared y plus 6x to the 4th power? Okay, so here we have different letters. Franz, you need to write. Here we have different letters. You still write it in descending order, but you do it alphabetically. So what we're going to do, which comes first, X or Y? x. So we're going to only focus on the x exponents. Don't even worry about the y's until you get all of those situated. Then you start looking at the other letters and putting them in descending order if you can. But the first letter in the alphabet in each term, is what we're focused on. So in this case, we're not even worried about the y. We're just going to put the x's in descending order. In this case, it would be 6x to the 4th. Now here, to answer your question new, like here's your subtraction. Again, it's not even going to move, but it would follow it if you needed to. And like this is a positive 2xy, so this would be a positive 2xy. If this was a negative, if this had a negative sign right here, I'd be bringing it with that term. So the sign right in front of the term follows the term. Sure.
So the number is negative and the exponent meant the number times itself. So if,
Well, that's only with the letter.
but if a letter is a number and that number times -7, would that be a negative something bigger number? And
So you're
that-
saying if we knew the value of x and y, is that what you're saying? If we knew that like x was 2 and y was 3?
Yeah, what if
Okay, in that case, what you would do, if you would substitute here, you would solve this like it'd be 2 squared. So it'd be 7 times 4 times 3, and then you would have your negative here.
how's it descending when negatives? What if negative numbers like this?
This is just a polynomial. They're not talking about the actual value of the whole thing. You're just to write your polynomials have to be written in descending order. It's not based on value, because like you said, it would possibly be different because we're throwing a y in there. So absolutely. Okay. Okay. Let's open up our books to page 372. Examples. Okay, everyone there? Page 372. And look. All right, here we go. Chap, wake up. What are the directions, Chap?
State the degree.
Very good. So all they're asking for is the degree of each term. So number 1 is 4x to the 5th times y to the 2nd. Keith, what would the degree of this term be?
No, 7.
Which is it?
7.
Very good. He is correct. It is 7. How many terms do you see here, Valeria? Very good. She's got it. We are adding exponents, and he's got it. It's 7. Any questions? Isn't this great for a Monday? This is not that bad. All right, now here, what is the degree of this term? This is what I was getting to right here. The degree of a constant is 0. So guess what the degree of this is? It's 0. That's the rule. That's the rule. So this is a term. A constant can be all by itself. If you ask what the degree of the term is, well, there's no letter, so it's just 0. Okay. Let's see, Morgan, what is the directions to number 5?
Oh, this is a long one, okay.
I know.
Classify each expression as a monomial
Wait, what?
Sorry. Monomial.
No, not monomial.
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 There you go.
Binomial. Trinomial. Other polynomial.
Polynomial. See, I called the right person.
Or not a polynomial. Then state the degree of each polynomial. This is like my favorite chapter.
Okay, so you've got a lot of stuff going on here. When it says other polynomial, so monomial is 1, binomial is 2, trinomial is 3. But what if, like, over here, this one had 4 terms, right? That would be your other polynomial. They don't have a special name. Or, yeah, quadnomial. But if it's going against the rules, then it's not a polynomial. And then the last thing they want you to do is state the degree of each polynomial. So let's look at 5. 4x cubed times y to the 5th plus 2xy. Ariel,
It's
how many terms is there?
there are 2.
So what kind of polynomial is it?
Binomial.
It's a binomial. Very good. Now, she's correct. Does everyone see that? 2 terms. I have 1 and 2. And I'm circling it without the plus sign just so we can focus on how many terms. Now, we have to find the degree of the whole polynomial. So what do I need to do, Ariel?
Add the exponents.
Of each term, right? So what's the degree of this term?
8.
And what's the degree of this term?
2.
Perfect. Which one? What is the degree of the whole polynomial?
8.
Yes, she is correct. It is 8 because it's the highest. Write this down. Chat, you had a question.
Does, like, for it to be a polynomial, does it have to be written in descending order? Or is that
Oh, no. Good question. In reality, when I'm grading your papers, it would be very beneficial for you to follow the rules. But I'm not going to mark it wrong if you didn't put it in descending order, kind of like some of the other stuff we do. Only because, yes, it's the rule. You will have a math teacher that may be, like, freakishly crazy on that rule. It's not wrong. I don't even think IXL would mark it as wrong. You see what I'm saying? So it does not make it or break it as a polynomial. It just makes some math people crazy. All right, so here's your answer. You should have 2 answers for this section. That's why I had y'all read, or Morgan, attempt to read the directions so we understand that you don't just read the first couple, oh, I know what to do. No, you have to have 2 answers. All right, number 7. Negative 4x squared y plus 5xy plus y minus 8. Now I want to point out that these are written in descending order. So let's look at number 7 real quick, because that was kind of a question for a lot of y'all. Notice, everyone, y'all pay attention. This is written in descending order. Do you see how it's x squared, then x? And then they focus on the y's. These are done, so they have y, and then the constant is at the end. Okay, so this is in correct format. All right, so Miranda. First, what kind of polynomial? Other polynomial. I'm just going to write other poly for short. And let's see, Miranda. You're correct. We have 4 terms. So it's other, or quadnomial, like Franz called it. So what do I need to do to find the degree of the polynomial? Of each term. And don't let that negative right there, these 2 negatives, don't let that, I don't even know why I include that. Don't let that throw you off. Don't think too much into it right now. All you're doing is the easy stuff. Just focus on the term. So what is the term, the degree of this term?
3,
The degree of this one?
2,
This one?
1,
And this one?
0.
Perfect. What is the degree for this whole polynomial? Yes, ma'am. Are there any questions about these? See, very little brain cells. This is perfect.
Would it be a time when it asks the degree of the constant?
Well, like right here. No, that would be the same as the degree of the term. That's why I said, you know what, I'm going to go and focus on these two because that's all you really need. It would always be 0. Okay. 9. 4y cubed over x squared plus y squared minus 1. Franz,
Yes.
how many terms is this? Or is this even a polynomial?
It's not a polynomial.
It is not a polynomial. We're
It's a
done.
fraction.
It is not a polynomial because there's a fraction with the exponent on the bottom. So it's not a polynomial. Can't do a degree. You're done.
You're good. Poly.
Poly. Not poly.
It would just be a negative.
Do what?
If you brought that up, it would be negative.
That's right. If we were to bring that up, it would look like this. And can we have a negative? No.
It's much easier to pronounce if you just said mono, bino, trino, and poly. You might just say China.
Okay. All right, 13. Let's do another one. X squared, y cubed over 5. Sophia, you're my victim. Plus xy over 2 minus 3 over 8. Oh my. Sophia, can you handle this? It's not a thing? Why isn't it a polynomial? Is that one of the rules? Can't have a negative exponent or an exponent in the denominator. This is all about negative exponents and exponents in the denominator. So, Sophia, are there any exponents in the denominator? So, therefore, is it a thingy? Yes, it is. So, what kind of thingy is it? Very good. It is a trinomial because there are 3 terms. So do y'all understand that? This is a polynomial because there's no exponents in any of these on the bottom. Yes. But there's no letter here. No, that would count as an exponent, so I do not think. Let me look. I do not see any trickery such as that. Nope, no trickery such as that. So, no exponents in the denominator. This is not a variable, so it's cool. It's fine. It is okay to have just a constant. Do y'all understand that? Got it? Memorized it? Good. Now, Sophia, what is the degree of this polynomial? Oh my. This term would be 5. What would this be? What would this be? Yes. Have confidence in your answer. You're correct. It is 0. There's no variables here, boys and girls. So therefore, this is considered just a constant. The degree of that term is 0. This one, you're just adding the exponents here, 2, and then here, 5. So then what's the degree of the whole polynomial, Sophia? Yes, ma'am. Look how smart y'all are. So here is the answer. It's the highest. Any questions?
Wait, have we gone back to degree of constants?
Yes, we've talked about that, Franz. Silly Franz. Okay. Let's look, last one, let's look at 17. Oh, that's ugly. Let's do it. Okay. One third x squared minus 6 x to the 5th plus 12 minus 4x. All right. Read the directions. Ariel.
I'm writing it down right now. Just give me 1 second.
All right.
Okay, it says write each polynomial in standard form.
Oh, standard form, standard form. What do y'all think that would be? Descending. That's right, Chap's favorite thing. Go ahead.
Then classify it by its degree and its number of terms.
Okay. Then classify it by its degree, like what we did over here, what the degree is, and by its term. So you're doing the same thing as you are here. The exact same thing, but this time we're rewriting it in the correct format. Okay, so let's do that. Ariel, what goes first?
Negative 6x, 5th power.
There you go. See that negative followed it. Now what?
And then the plus 1 over 3x squared.
Uh-huh. And I'm going to cross these out as she does them. Then?
And then there is negative 4x.
Yep, and that negative followed it. And then last but not least?
Plus 12.
Okay. There you go. That's correct. That's your first answer. What kind of polynomial is it?
Other.
Okay, it's other polynomial. I'm going to write that right here. Other poly. And let's talk about the degree of the whole thing. What's the degree of this term?
5.
And this one?
2.
This one?
1.
And this one?
0.
So what's the degree for the whole thing?
5.
Perfect. Any questions? This is your whole answer. You should have 3 answers. None? All right, you are doing page 372. Numbers. No, shh. Six through 20 even. That's like A problems. I think y'all, ooh. Yeah, I'm not going to have you do the other stuff. Y'all just had a stressful week. So it's due Tuesday. I will be assigning IXL tomorrow. And you will have a quiz coming up, like either Friday or Monday. I can't remember when.